The first test of this family of comparisons of means of two populations is the one where we can assume known variances. So that's the case where even though you're given two samples, you might be considering that even though the samples have their standard deviations, maybe the producer who has produced a specific device that gave the measurements has done millions of tests and has verified that theoretical variance for that device is given by a specific value and wants you to use that theoretical value. So in that case, the uncertainty related to the variance is eliminated and we use Z procedure. That means that we will be using normal distribution. The standard error looks very similar to the standard error with the sample standard deviations, but now we use the theoretical values in here. And then the test statistic, which is now Z statistic, since it comes from normal distribution, looks again similar or the same as in the other test. So if we test for the difference of the two population means equal specific value of delta, then the Z statistic is the difference between those sample means with that delta value and then divided by the standard error. And the decision is done again in a similar way. So if our Z statistic is significantly close to 0, so within the critical range, then we fail to reject null hypothesis or just say that we accept it. And otherwise we reject null, which means that the test statistic would be unlikely to happen if the null hypothesis is true.